Hi there, and thanks for watching this new video demonstration. In this video demonstration I would like to explain you a new capability that has been introduced into the Moose framework, and that is to set up an automatic and comprehensive air-to-air defense system using AI units. The new class has been introduced to accommodate this, and the class is named AI A2A Dispatcher. I would like to thank Stonehouse, Pikey, Delta for their help in testing and in explaining what is essential to develop this air-to-air dispatcher component within the Moose framework. In order for you to understand quickly what this new capability is doing, I have created this demonstration mission here that I'm going to document in further video sessions in great detail. Let's take a look at this demo mission, what it does. So basically what we have is we got some blue planes here which are being spawned dynamically using the spawn class, and they are going to fly up to the north, engaging the red border, crossing the border here, which is defined as a polygon zone. And once they cross the red units defined here, or the red air bases that are here, will spawn automatically air defenses and will engage with those blue units flying up to the north. The air-to-air dispatcher uses templates of planes. So basically I have set up a couple of planes here that are the templates for the red planes, and my spawning algorithm, I've defined here a couple of example planes to really set up a diverse amount of planes that will engage with the enemy. The upcoming enemies, the blue planes, are being detected, and you need to set up an EWR, or an early warning radar network, into your mission, consisting out of long range radar units that are detecting the upcoming planes. You can even set up an AWACS here that's airborne and is flying around, that will become part of the EWR network. And once blue planes are being detected and they are crossing the border, and that's an option, by the way, this border, then red planes will spawn at air bases that you defined, and they will engage with the upcoming enemy. So the air-to-air dispatcher class contains new functions and new methods and new concepts to set up automatic air-to-air defenses. Let's go through the explanations. I've created a presentation here, and I really suggest we do a walk through the explanations so you understand from a high-level overview what the new class is doing and how it works. The air-to-air dispatcher is defending from upcoming attacks from the other coalition, and doing that in an automated way. You can define a border. You don't have to, but you can define a border around the area that you want to defend. You need to set up an EWR network. The early warning radar network can be set up by long-range ground-based radar scanning capabilities or units, or you can use airborne units like AWACS or any other airplane that has radar searching capabilities. This is new, so those who are familiar with the old GCICAP script may notice that a new concept is now introduced, and these are squadrons. And squadrons are basically named groups of airplanes that are located at an airbase, and these squadrons have multiple airplane templates that can be utilized within the air-to-air defense system. Squadrons have resources, not unlimited, so you need to specify the amount of airplanes that are available for that squadron. Squadrons in real life fly most of the time an airplane of a specific type. However, those airplane types may be armed with different payloads, so the templates more can be used to express the different weapon configurations that are applied to the airplane type. And potentially you can also define for one squadron multiple airplane types that is flown by that squadron. Specific squadrons within your mission setup can be commanded to perform control air patrols, or CAP. Control air patrols are basically commands where planes from your airbase depart and will start patrolling within specific patrol zones. And they will do that continuously until they get out of fuel or until they get damaged. Control air patrols are being used to ensure that when attacks are coming from the other coalition, that very quickly these attacks can be countermeasured by sending those airborne planes directly towards those attackers. How does this work? The EWR network is scanning for targets continuously. And once intruders are being detected, then those intruders, they will typically be planes, that will fly in formation. So these planes will be grouped into areas with a specific defined radius. That allows you to, that allows the system to be very efficient in target definition. And typically the defense system will also consist of plane groups that are flying in formation. So using this system, multiple planes will engage with multiple targets and will create a comprehensive air combat scenario. The engage system is working in two modes. Once targets have been detected, then the CAP groups that are airborne will be evaluated to be engaged to those targets. But once there aren't any enough CAP groups airborne, then from the air bases that are being commanded to do ground control intercept or GCI engagements, then the nearest airbase to that target will launch an GCI group, and those planes that are taking off from the airbase will then immediately engage with those targets. The engagement can be done in the A2A Dispatcher in two modes. There is a hot war scenario and a cold war scenario. The cold war scenario is where you have defined your border of the area that you need to defend. Then once the intruders cross that border, then the targets will be engaged. While if they would be here flying, they wouldn't be engaged. A hot war is where the war has already been escalated, and any target even beyond the detection zone will be engaged immediately by the defenses. Let's have a look what it means when you have sufficient airborne defense capabilities near the target. The A2A Dispatcher can be configured with an engage radius, and an engage radius is basically a virtual circle that's been drawn around each detected target, and any airborne friendly that is near to the target within range will be evaluated to be engaged. Kind of friendlies that can be airborne near the target can be, CAP flights that are patrolling, but can also be intercept flights that are returning from another successful dogfight that where airplanes have survived. So within the engage range, CAP flights and returning intercept flights can be commanded to engage to new targets. There is another parameter on the squadrons, and that is the overhead of defenses. The airplanes that are being used as part of the defense system, or that are being used or flown by the squadron, can be of different types. And because airplanes, are from different generations, some airplanes may not have the latest technology to, conduct air-to-air defenses, and more airplanes may be needed to countermeasure the newer type of airplanes that are approaching here. And this is what we call an overhead or an efficiency of the defenses. Squadrons can be commanded to launch a larger group of airplanes into the air than what the intruders are likely to engage with. And this is also being given, as a relative parameter. So the overhead parameter is not saying you need to launch 4 airplanes every time. No, it will be calculated dynamically based on the amount of intruders that have been detected. I've seen during my testing, for example, that a MiG-31 with long distance, air-to-air weapons will be less efficient. Although it's a very fast plane, those weapons are less efficient to engage on, let's say, the latest F-16 airplanes. You want to ensure that you launch sufficient MiG-31 airplanes into the air to defend and countermeasure the upcoming F-16s. Another one is the grouping of defenses. Because squadrons fly in formation, you can command these squadrons to group the air defenses into an amount of airplanes. And this can be really set up per squadron. So you can command certain squadrons to group by 4, by 3, by 2. The squadron has different methods to take off from the air bases. Because the DCS airbase coordination system, or APC, is not efficient or contains a lot of bugs, the new air-to-air dispatcher contains different methods how to spawn new airplanes. The method that will give you the least problems is to spawn the airplanes right in the air. So once intruders have been detected, you can command those airplanes from that squadron to launch those airplanes immediately in the air and engage on the targets. Or you can command them to be launched at a runway. The most realistic scenario would be from the cold parking spot, or you will command them from a hot parking spot, and that is with running engines at the parking spot. Similarly, a squadron can be commanded to apply different landing methods. So once airplanes have returned to base after a combat engagement, then those planes can be landed in different ways. Okay, so let me explain you now how you set up your mission. And for this I've created as well a couple of slides so that the explanation can be done thoroughly. And so the first thing I did in this demonstration mission that I showed you is I set up EWR units. Typically you got these types of units here that can be applied, which have long radar detection capabilities. But you can also apply other radar capable units, for example an AWACS or any other plane that has long-range radar detection capabilities. The position where you place these EWR units is very important. So if you put them directly near the border, then the war in a hot war will escalate immediately. The next topic, you can define the border zone, and the border zone is basically you define a border area using a polygon zone. So how do you do this? You set up the border using the waypoints of a helicopter group. So you deploy a helicopter group in the air, you put it late activated with a flag, and then you define using the route waypoints that polygon zone, and then later within your mission script you will use that helicopter to set up the border. This helicopter will not be shown during mission execution. The third is that you need to define plane templates. Remember, each squadron can have specific template types or airplane types. In my example I've just defined 2, which is basically very simple, just an airplane group that you define with the characteristics. You can define payloads, you can define skins, fuel, and important is the name. So the name that you give to those templates need to be specifically named, because those names will be used within your mission script. So once you got the planes, the templates here defined, then the fourth option is that you need to define the cap zones. You define the cap zones again by different methods. The first method is using polygons. So again you deploy a helicopter unit here, airborne late activated, and you define the waypoints here. And the waypoints will be used for the polygon parameters. Here I define a cap zone west and a cap zone east. Okay. You can also use a trigger zone. In this case cap zone middle. So I define a trigger zone here, which is a radius, a circle. And so now, as I said, the new air-to-air class or dispatcher class is using Lua code to actually set up your defense system. It's not a rocket science. So basically what I'm going to show you is the syntax that you need to apply to set up that defense system. And this is basically a template. And what I've done is I've taken the script, created here in presentation mode the different commands that you need to execute within your mission to set up those defense systems. First thing you need to do is you need to script the EWR network. Remember, you've deployed those groups here in your mission. And now what you're going to do is you take the names that you have defined within your EWR mission and you're going to link that into your script. How do you do that? Well, the first line is you will set up a object from a set group class and you construct it with the new, and you store that into a variable detection set group. Then from that variable or that object you can then use the method filter prefixes, open brackets, and then in accolades, which is like an array, you can define strings of the different names of the groups that define your EWR network. And then using the next command, filter start, what will happen is this object detection set group will start scanning for any name that is starting with dfccp AWACS or dfccp EWR, and will include those groups into the set group object here. So as a result, you will have in this scenario here 4 groups being included in the detection set group object. When new objects are being spawned dynamically, or when objects are being destroyed as a result of the war, then those groups will be automatically removed from this detection set group, and you will end up with less detection capability, or you can increase the detection capabilities. You could, for example, spawn a new AWACS during your mission execution at a certain point in time. If you name it dfccp AWACS and then whatever comes behind doesn't matter, then that AWACS will automatically be added to your EWR network, and you will increase your detection capability. So the next step in the scripting is that you need to define your AI A2A Dispatcher object, and you need to configure it. What you do is you write AI underscore A2A underscore dispatcher. This is the class name, the prototype of the class, and you execute the new method. What you do then is you, as a first parameter, you pass the detection group object that you defined to define your EWR network. The second parameter is the radius of the grouping. So once new targets have been detected that are approaching, they will be grouped with a radius of 30 kilometers. One would be 1 meter, so you say here 30,000, so 30 kilometers range. So if you got groups here and groups there, then you will have two targets approaching your area. The next, and this is not a mandatory thing, but you can set up a border, and that was the border that we defined here. Remember? So how do you do this? Well, you can use different zone types, and this is something you really need to look up within the Moose framework. What are zone objects? So what I'm doing here is with the helicopter that I've defined a polygon. So I'm using zone underscore polygon class. I give the thing a name, CCCP border, and then I am using the group name, CCCP border, which is the name of the helicopter group, as the parameter, the second parameter, to create the zone polygon object, which I'm storing in CCCP border zone. Using the AI dispatcher object that I have created here, I can use the method set border zone, where I am passing the parameter CCCP border zone as an array. The third parameter is also a parameter that's really important, because that will define the engage radius. And the engage radius is something that I will document in greater detail, what the different effects are of this value. But basically, for the moment, just remember that if you specify here, 300,000, that means that any airborne unit that is within a range of a target, within a range of 300 kilometers, will be evaluated to be engaged to that target. If you specify 100,000, then the range will be smaller. If you specify 50,000, then the range will be 50,000. So within a range of 50 kilometers from the target, any airborne target will be evaluated to be engaged. Otherwise, a GCI unit will be launched from those airbases. The next step is to set up the squadrons. And the squadrons is basically which squadrons do you want to locate at which airbase. So basically you define here which airbases are going to engage with, or going to, form part of your A2A defense system. So you have a method at the A2A Dispatcher object that you created called setSquadron. You give the squadron a name. You specify the airbase from where the squadron needs to be launched, and the airbase object has, for the Caucasus, the default map, all the airbases listed as an enumeration type. Then you can define, the template name or the plane name. Remember here, SQCCP SU27, which is the late activated template that you can apply to the squadron. And you specify here with a value of 20 that you have 20 airplanes within the resources system. So basically what you say here is that you got Su-27 planes, you got 20 planes available within your resources, and you will launch them from the airbase, right? And you give the squadron the name Mineralia, which is the key to set up further options of that squadron. And you can do the same for any other airbase or any other squadron that you want to set up. While here I'm configuring a MiG-31, and here I'm configuring again Su-27 planes at different airbases. You need to learn this a little bit, but once you get the hang of it, this will be really, really very easy to use. I promise you. Okay, the next step is that per squadron, you got squadron functions here. You can now use A2A Dispatcher object to set up the squadron overhead, which is a value where 1 is the neutral value, and any value bigger than 1 will create a bigger overhead, and any value smaller than 1 will create a lesser overhead of the defenses. I'm not going into detail what this value does specifically, but just remember that you can set up an overhead value. Another is the grouping, so you can set up grouping values per squadron. That means that any plane that's being launched, will be grouped by sets of 2 here in Mineralnie squadron, or in Sochi squadron it will be grouped by 2 as well, or in the Novo squadron they will be grouped by 3. And I'm going again in a separate video what this parameter will do in more detail. You can set up the takeoff methods. There are different methods within the in the dispatcher object here now available. So you can use set squadron takeoff in the air, from the runway, from a parking cold spot, from a parking hot spot, and you specify which squadron applies to that parameter here. So Mozdok will start from the runway, Makeup will start cold, Novo will start hot at their respective airbase. Same for landing, so you can say I want to land at the runway, so once the plane touches down at the runway, the Mineralnie squadron units will disappear near the airbase, so once they're still airborne and returning at Sochi, those airplanes will be disappearing, and so on. So you can see the comprehensive options right now that you can set up for squadrons, fine-tuning your air-to-air defense system. Then the CAP operations. So once you've set up your squadrons, you can set up as well per squadron what CAP areas you want to use for the control air patrols. So here you set up using your helicopter objects that define your CAP areas here. You use the zone polygon here, zone class, to set up new CAP areas. So what you do here is, again as in the border, you create a new zone polygon, you give the zone a name, and you give the group name of the helicopter that defines the CAP zone using its route points. Then you say to the air-to-air dispatcher object that the Mineralnie squadron needs to patrol in the CAP zone east, which is this one, CAP zone east zone, with a minimum altitude of 4,000 meters, a maximum altitude of 10,000 meters, a minimum speed of 500 kilometers per hour, a maximum speed of 600 kilometers per hour, and an engage speed of 800 kilometers per hour, minimum and a maximum engage speed of 900 kilometers per hour. What is all that? It's basically very simple. You command the Mineralnie Vody squadron located here to start patrolling in this area here with an altitude between 4 kilometers and 10 kilometers between the speed, so they will just fly around, and the speed will vary from 500 kilometers per hour to 600 kilometers per hour. Once they are commanded to engage to a target that has been detected, they will engage to the target with a speed of 800 to 900 kilometers per hour. The same for the Cap Zone West. So Cap Zone West is a polygon set up here. It's a bit hidden, but basically the same thing. Okay. The next script that you need to look at is the zone middle. So the trigger zone was used here to set up the zone, so you need to use a different class. It's called zone, new cap zone middle, and that's the name, also the name of the trigger zone that you defined within your mission editor. And then you use that cap zone middle as a second parameter to the set squadron cap command. Again, 4000, 8000, 600, 800, 800, 1200. And then radio. What is radio? It's basically the altitude mode. So once it is patrolling, and if you're patrolling above a mountainous area, you might want to use the radio parameter to ensure that planes are always using this altitude above the ground level, not the barometric level that has been measured within the air. While here, if you use baro, or if you don't mention this parameter, then the patrol will be done at barometric altitude level. I haven't really explained yet the set squadron cap interval. So basically what that is doing, it says for each squadron how many groups can be active at the same time, and it specifies the timing interval 30 to 60 seconds. So each 30 to 60 seconds it will be evaluated if a new cap group needs to be launched. The one parameter is the chance that a cap will be departed within that zone. But for the moment, just press 1 here. I've put this in to extend the framework on a later basis. Okay, so let me summarize. So what you've done here is you set up the cap zones, west, east, and the middle, which is a trigger zone based zone, and you specify the altitude, minimum, maximum patrol speed, minimum, maximum engage speed, and the altitude measurement method that's been applied, which is here barometric and here radio based. And you apply those to the squadron. And there's a typo here. I apologize. It should be makeup here, not Sochi. Okay, so once you've done that, and the last thing that you can do is you can specify within the air-to-air engagement defensing is which of those squadrons will be GCI based tasks. So what you'd say here is that Novo squadron will execute a GCI once there aren't any airborne friendlies within the range of the detection. So then from those air bases, GCI squadrons will be launched, and they will engage the targets with a speed of 900 to 1200 kilometers per hour, 900 to 2100, and so on. Just bear in mind that because you can specify different airplane types or airplane templates per squadron, the speed of engagement can differ. So let me explain now in a running mission how all of this looks like. So I got this mission here. I got the attacker set up as spawn scheduled objects. So I got blue units here, F-16s, F-16A, so on. They're approaching these areas here in the north. And right now I got this one here that's been set up. Right, that one got launched from the runway. Oh, by the way, there's a display panel that shows you the tactical overview, which targets have been detected, which planes from your defense system are engaged with which targets, or which planes from your engaged air-to-air defense system are patrolling or are doing specific tasks. It will also show you the status of what each air-to-air defense unit is in. So it could be patrolling, but it could also be out of fuel, it could be damaged, it could be lost control, or it could be engaging with specific enemies. So now it says that 3 cap groups have been launched into the air. Right, so these are those and these are the other areas. All of these are commanded to be launched within the air. Yeah, so they will not be on the runway taxiing towards the runway. They will just immediately spawn within the air and start patrolling. So once those blue planes will cross the border, only then the engagement will be executed. This is a Cold War situation. So now you can see that a target area 1 has been detected, containing 2 enemy planes called NATO 1001-01, NATO 100102, which is a group basically. Yeah. So the detection algorithm will group that group automatically with a range of 30 kilometers. So any plane within 30 kilometers will form part of that group. When you look to the script that I have used here, and here's the script, I set the engage radius to 80 kilometers. So any airplane that is currently within 80 kilometers from this group here will be engaged to that target. So let's measure. Is this 80 kilometers? No. This one? No. So what the system will do then, it will say, I don't have any airborne friendlies near the target, so I will launch a GCI. And it will launch the GCI from the nearest airbase, which is here, Novo. I haven't defined any defenses here, so nothing is launched from here, only from here. I commanded from Novo to start at the airbase there and to start the takeoff parking hotspot. Alright, so those airplanes are starting with running engines and starting to taxi to the runway for takeoff. I'm speeding up a bit. Those who are concerned with performance, I've created a system that uses minimal performance overhead into this engagement. So while that one was starting up, the second set of targets have been detected, which is Area 2, containing 2 units again, NATO 200102, NATO 200103. And these are engaged by a cap. So let me show you here what happened. And this is interesting. When you look to the NATO 2001, you'll see that 3 targets are there, part of the group, but only 2 were detected. So it reports 2, and the range was within 80 kilometers. So this patrol here has been commanded to engage to those targets here. And that's what this tactical information is showing. So now is very interesting. So remember, only 2 are detected, but now 3 got detected. So what happens now within the system is 2 are engaging, which were the patrols, but an extra GCI now is being commanded to take off from here. This MiG-31 will intercept and will go to this target here. And why is that 38? Because this is the closest GCI airbase that has been defined near the target. This is 138 kilometers far, while this is 153 kilometers far. This one is starting cold. Why? Because I commanded in my script here those to be starting from the runway cold. Makeup. This is makeup, right? Yeah, cool. So then you see that MiG is going to start up its engines. I'm going to speed up a bit. And it's starting to taxi towards the runway. And while flying, let's observe the tactical situation that's evolving. Now what happens? A target area disappeared. Why is that? Let's have a look. Oh, the Su-27s engaged with the enemy and has eliminated the upcoming targets. So now what happens with the Su-27s? They are returning towards the airbase. There were GCIs, Su-27-004, returning to the airbase. And they will return here, back for landing. While these ones now are starting to engage. Interesting. And the GCI here is taking off. And you see the engagement still in the state is executing. The GCI unit, the MiG-31, is still approaching to the engagement zone because the battle is still going on. The other ones are returning to airbase, and now this is a successful hit as well, so that target area has been eliminated as well. And you'll see now the MiG and the Su-27 back to patrol, right? While the GCI is returning to the airbase. Yeah. Okay, I'm not going into great detail into this video, but this shows the concept of how the air defense system is working. And I really hope that, you know, don't shoot this off from day one. I hope you really find this an interesting class. We all hope that. I would like to express a special thanks to Stonehouse, because he has been helping me a lot in explaining what the current GCICAP capability is doing and what were the pitfalls and the difficult areas and where improvements could be done. So a big thanks to him. As well, I hope Snafu, well, I hope he appreciates this new development. And well, thank you all for dialing in and joining this information session. I'm going to make sequence shorter sessions going through the different options in more detail and explain what they do. So before I finish the video, let me show you the documentation of this class. So it's on the Moose Framework main page, and I've reworked it a bit. So you got Moose Framework here, demo missions, and then the human tasking classes, which are here, and then the AI controlling classes, of which the AI air-to-air dispatcher forms part of. They will come an air-to-air, no, beside an air-to-air, there will come an air-to-ground dispatcher. And the reason why I haven't named this GCICAP is there are other kinds of air-to-air engagement types that also need to be probably dispatched later on. So this allows me to extend this class with new functionality as time moves on. Same for air-to-ground, and maybe later air-to-naval, and maybe there's some other dispatching classes that will emerge later. So let me click on air-to-air, the AI air-to-air dispatcher here, and then you'll move to this module description here. So the authors, Stonehouse, Snafu, which of the original GCICAP script, myself working with the guys to rework this and the introduction of the new concepts, etc. When you click on this one, the air-to-air dispatcher module, then you'll see a comprehensive explanation of this presentation with text, explaining you the pictures, the methods, you know, like how to use them and so on, the parameters, as well the explanation of how to set up the EWR network, how to define the zones in your mission editor, and how to script it. So there's a demo script listed, and then an explanation here how to, you know, implement the script with some additional informations. If you have questions, please direct them, you know, on the YouTube channel, or just write on the forum, or any place where you can contact us. Thank you for watching, and I hope to talk to you soon. Bye bye.